Afternoon and good evening, depending on your time zone, and welcome to the fifth and final virtual peering series Africa session for 2020. My name is Andrew Owens. I'm the peering and interconnection manager at Teraco Data Environments, and my day job is NAP Africa. 2020 has been a roller coaster year for obvious reasons, but today we wanted to revisit the thing that we were all talking about before the pandemic hit the globe, and that is the impact of submarine cable cuts. And hopefully that's going to be the last time that I have to mention COVID. Today I will be co-moderating with Matthew Chigwende, and I'm going to hand over to him to do an introduction.
Hi, good afternoon and good evening, wherever you are. My name is Matthew Chigwende, Group Head of Network Engineering at Liquid Telecom. Okay, so thanks, Andrew. Now let's just talk. This year, as he said, has been quite a challenging year, and I would want to say well done to each of you for doing your part to keep our internet in Africa working. And also thank you to our sponsors for this event, Flex Optics, Facebook, and NAP Africa. Thank you for making this all possible. Right, let's go to some housekeeping rules for this event. So just to note, this session will be recorded, and the recording will be made available after this session. We are also streaming live, so if you are Facebook, Twitch, and Periscope, you'll be able to see the streams. One thing we always say is to be tolerant, to engage respectfully, and act responsibly. And also, we would want you to be as concise as possible when asking questions or speaking. Just keep it as straight and short to the point. For your questions, will you please format them with your first name and the country? Like example here, Emily, Ethiopia. Then you write your question. Please familiarize yourself with the Internet Society's Code of Conduct that is found on the internetsociety.org website. So to engage, would want to encourage you to engage with ourselves. The panelists here, please use the chat room to discuss with the other attendees. This is our time to meet. We're so used to doing this face-to-face, but this is our chance to meet as African peers. So let's use the chat room to discuss with other attendees. And also, if you are not speaking, please make sure you are always on mute. And if you have, this is very important, if you do have a question, post your questions on the Q&A room and not in the chat room. So you'll notice on the bottom bar, there's the chat room and the Q&A. So make sure for all the questions, you use the Q&A. So also make sure that you follow the social media with those hashtags, IPA in Africa, virtual peering, and IXP, the hashtag ISP. Just for those, just to make sure that we cover all the languages that are available to us. Audio language is English that we are supporting now, but there's also a French translation, and some video captures will be in English. So over to you, Andrew.
Thank you very much, Matthew. And once again, I just want to reiterate, thank you very much to the sponsors. None of what we do would be possible without them. So today we're talking about submarine cables and what happens when they break. And when we talk about the internet, it's an intricate web of interconnected pieces, and each entity relies on a different entity to be able to operate. And over the years at AFPIF, I recall we traditionally focus on peering, internet exchanges, interconnection, content, data centers, that sort of thing. And it just feels like we haven't paid much attention over the years to the role of submarine cables, because it's not something that you can see. We just know that the cables are there, and we just assume that they are always working. Given 2020 time, what feels like a very long time ago, even though it was only in January and April of 2020, we saw simultaneous disruptions on the West. On both of those occasions, simultaneous disruptions, and that had a devastating ripple effect on connectivity across the continent. And as I mentioned previously, that was the thing that we were talking about before we knew any better. And I remember specifically having a discussion with somebody after the first cuts in January, and the person mentioned to me that 2020 couldn't get any worse than this. And well, welcome to 2020. So today we're going to look at those submarine cables, why they happen, what the impact is, and interestingly, how they are repaired. And we're going to kick off with Clementino Fernando, who is a telecommunication engineer. He's worked at Angola Cables. He has been a cable landing station engineer and a project manager on the SACS project, the South Atlantic Cable System, and most recently as a transmission operation coordinator. So Clementino is going to kick off today's session with a breakdown of the submarine cable repair process. And following on from that, we're going to have a panel that discusses the behind the scenes activities that take place during the disruptions. So if I can ask Clementino to please share your screen, and we can get started.
Okay, thank you. Good afternoon, good morning, depending on geography. Okay, let me get started. I think I should stop this and then, sorry. Okay, thank you again. Basically, in today's presentation, I'm going to talk about a little bit some executive summary and a typical submarine system, as well as showing what submarine cable map, because most of the repair, most of the discussion or most of the presentation will be based on WACS cable system. I'm going to explain a little bit about the call out the vessel when we experience a cable fault and mobilization for location, gathering the relevant useful information. I'm going to show you some cable ships, how it looks like. And I'm going to talk about the initial and final splice when the cable arrives to the fault location. And I'm gonna tell you about the cable breaks in general, how frequent and the causes average time to repair. And I'm going to talk about some impact being experienced in Angola, but in general itself, and some recommendation and conclusion. Okay. Moving on, as a good practice in the submarine industry, to operate the submarine cable, it's always to have a marine contract in place, because this is a good practice. Sometimes people think that a submarine operator owns the cable ship, but that's not true. It's not even practical. it's very expensive to own the cable ship. That's why the good practice is to have a marine contract with a marine company repair, so which can repair the cable whenever you experience a cable fault from the beach manhole to the beach manhole. Okay, I'm gonna highlight here about the ICPC, which is the International Cable Protection Committee, which focus on promote the awareness of the submarine cables and some protection recommendation, and it's a good practice as well. Okay, this is a typical submarine cable system. As you can see here, we have the dry plant where the terminal station equipment are, which is the submarine line terminal equipment, as you can see here, and the power feed equipment. Okay, and then we have the wet plant where we have the submarine cable branch units and repeaters underwater. So basically, this is the traditional model of architecture of the submarine cable system. Okay. This is the WACS submarine cable map showing the country that the WACS cable passing through, starting from South Africa, Namibia, Angola, and it finishes in London, United Kingdom. Well, in this session, basically, I'm gonna talk about the call out of the vessel. So basically, when we experience a cable fault, first of all, we need to do a formal request to the cable ship, which are the responsible for the cable repair, which in this industry we call them as a duty officer, to basically officialize the mobilization request. So when we do that, basically the duty officer have to acknowledge the receipt of mobilization request. And of course, in this process, we need to make sure that the cable is really cut or even experiencing a shunt fault, because as you guys know, to mobilize the vessel is very expensive. And we need to make sure with some relevant tests that usually cable landing station engineers perform in the station. Okay. So once the official request from the cable owner is in place, and then there is a couple of discussion that's going on between the duty officer or the cable ship repair and the cable owner. In this particular case, for instance, I can consider the cable owner as a WACS consortium in order to coordinate how the activity will be. And it's really important in this process to make sure whether the fault location is in the territorial water or in the national water, due to the permits, the one that allows the permits to enter to a country if it's on a territorial water. If it's not, it's really very easy, because the vessel itself doesn't need to apply for the permit. It just comes straight from where the vessel is based in. Okay, and then we have to develop together the repair planning and get this approved, as well as the method of procedure. Well, basically, the method of procedure is a step-by-step sequence of an action to be executed by a technician performing an operation or action that implies a charge of state. So when all of this is settled, and then there is a couple of things that the engineers need to perform, which is the station, which is the COTDR testing. from the cable landing station, because when we experience a cable fault, not necessarily we are talking about the cable cut. Sometimes it's a cable shunt fault, and shunt fault is electrical failure, and sometimes it evolves to a cable cut. But when it's a cable cut, it's very easy to locate the fault location, because we just perform a COTDR test. This COTDR test is different from OTDR, the one performed in the land cable. This is a current OTDR, because when you perform this test, you have equipment, active equipment in front. So you need to have this OTDR to get you the result. Well, another test that needs to be performed during this time is the PFE power reading. So PFE basically is the power feeding equipment, the one who feeds the power to the repeater and the water. So usually when you have the voltage fluctuating or the voltage drop, sometimes it means that it's a shunt fault. It's not a cable fault. Well, and then you have insulation resistance test on the land cable, basically from the land cable, from the bitumen node to the land cable. This is to make sure that there is nothing related to the land cable fault. And then when we have all these tests done, we have one document that we call RPR, which is routing position list, where we have all submersible information about the work plan in terms of distance, water depth, etc., distance between the repeaters. So once we have the distance, and then we need to inform the cable ship repair about the distance, etc. So they can make up the proper plan for them to come to the fault location. And there is one other step that we need to perform, which is the chart. In the chart, we have this bathymetry information, whether it's a sand area or rock area or even mud. All these information needs to be looked at in order to make sure that which strategy that the cable chip repair needs to arrange in order to perform the repair. Well, this is some relevant information that usually the cable ship asks prior to the vessel mobilization, which is they usually ask the type of cable fault, whether it's break or shunt or even other. As I mentioned above, during the fault location, we can assure that the type of cable fault is break or shunt. If it's shunt, and then we internally we need to make some arrangement in order to keep the trough up by adjusting the PFE configuration. Well, and they also ask the location distance, as I mentioned above as well. The distance between the repeaters or the fault location from repeaters. Okay, if it's a shunt fault, okay, PFE voltage current readings. This is being mentioned above, and I'm not going to mention about that anymore. Okay, and the water depth it's very, very important, the water depth, because the big vessel, which is the main vessel, usually has a limitation to approach a certain water depth, which is maximum 15 meters. If the water depth is below this, and then the cable ship needs to arrange a supporting vessel, which is a small barge, to approach the water depth according to the fault. Okay. Well, and in this section, the vessels will need to ask or to make sure that the cable landing station has the 25 head ton available from the terminal station. This this frequency is really important, that usually is performed from the PFE once while the cable is being located. Okay. Okay, this is a good example of cable ships. If you can see the big vessel above, and then below you have the small barge, which is the supporting vessel. And then you have the actor, which is the ROV, the machine that usually is deployed underwater to, to catch the cable or to bury or unbury the cable. This machine is basically operated remotely from the cable ship. And then the other picture shows the vessel deck with some cable being recovered. Okay. Well, here we have the initial and final splice. As you can see, some buoys underwater or in the water. Basically, when the cable arrives at the fault location, the first thing to do is to run a grapnel and these two machines down here. Grab and round and holding machine. One is to to catch the cable, and the other is to cut the cable. These two machines is very important once the vessel arrives to the site or to the fault location. And then when he catches the first side of the cable, and then the crew member or the crew member of repair, they perform the initial splice. As you can see here, the guy with the phone, this is the initial splice being performed. And then when the initial splice is performed, and then they deploy the cable and they put them on the buoy, and then they do the final splice, which is by cutting the another side of the cable, and do the same process. And then they perform the final splice. As you can see here, the crew member pulling the cable to the water after the process is done. Well, here I have cable breaks in general. Basically, once the submarine cable is installed, nobody expects any failure unless it's a natural factor. So talking about the frequency, basically is something that nobody's expecting because it's really expensive to perform any repair. But usually the cable break frequency depends on the seabed condition, how protect the cable is against the third-party aggression, as well as the installation methodology applied based on the road survey. As you guys might be aware, the last fault that we experienced on wax early in January on Congo Canyon, it was due to current, turbidity currents coming from Congo River. So basically, this is a natural factor. So I think the earliest fault was in 2006, and then this in 2020. Basically, since the wax cable and SAT3, it was a two fault at the same time which affected the two systems, SAT3 and wax. Since the SAT3 was installed, they've never experienced a cable fault by a natural factor, especially this one coming from Congo Canyon. Well, and that was something that wasn't expected. Okay. Well, talking about the causes, usually the main causes I mentioned above is a natural factor, cable abrasion, cyclone, third-party aggression, fishing activities, anchorage, poor installation, etc. And the average time to repair basically depends on the cable length and the water depth, as well as the weather condition. But in average, it takes 28 days or even less, including the transit of the vessel from where it's based in. Usually the vessel is based in a different country, and then they have to move from one position of where the vessel usually is based in to the fourth location. It depends where the fourth location is, and then it will lead the time lead for the repair. Well, here I have some cable breaks in general continuation. Basically, I'm going to talk about the protection methodology. We have here Euroduct, this yellow, and then we have articulated pipe, and then we have pinning and the rock area, if it's a rock area, of course, and then we have sandbags, then we have cement bags. So this is one of some of the methodologies using during the cable protection according to the sea bottom profile. As you can see, the guy, the diver in the underwater is trying to move the cable and the rock area because the cable is suspended. Usually when the cable is suspended, it doesn't matter if the cable is protected. So you need to remove the suspension because it's still in danger. In case of an anchorage, the cable can be cut anyway. Talking about the impact, well, typically impacts on country communication by increasing the latency depend on the cable system. In the case of a country only depends on one submarine cable, it's usually affect the whole communication, okay? And for those one who has more than 2 submarine cable system, they can always restore its traffic to another cable system, because in submarine industry we have this agreement. Whenever you experience a cable fault, you can restore your traffic to another cable system if this agreement is in place. And this is what people usually recommend to the customer when they come to buy a service. Okay, it's also impact on a system availability being agreed with the customer in terms of service level agreement, which is the SLA. Because usually when the impact, when we experience a cable fault, it takes more than 20, 25 days or even a month without the traffic. So usually it's a huge impact. Okay. For those who have replied to the restoration service, whenever they experience an outage, their traffic is immediately restored. And then we have 2 kinds of restoration. We have in-system restoration in the case that we have how to restore when we have only in one segment affected. We can do an in-system restoration. Then if it's not possible, we have to do outside restoration depending on the cable system. Here I have some faulty cable evidence. This one, the white one is the one being taken on Kenya, Congo earlier in January. Basically the cable burned, during the fault. It started with shunt fault, electrical failure, then it burns the cable. So the other cables is a double armoring cable. As you can see, the difference between one cable to the other is because this one is lightweight. Basically, is the cable which is installed in deep water, which doesn't need an additional protection. But the other one, double armoring, usually this kind of cable are installed in shallow water where requires more protection. Okay, this is the same cable that I was mentioning, the white, which is lightweight cable during the Kenyan-Congo fault. And the other picture over here is showing the splicing on board. And below we can see the crew member working on the deck of the vessel, and the other one is they are pulling the cable. The machine down there is the grabner, the one that catches the cable when it's underwater. Usually they apply it during the repair process. Okay, and here I'm going to talk about some recommendation. It's highly recommended by the ICPC to oversee the cable on the sea, especially in the shallow water. And the frequency must be twice a year, depending on the seabed condition. For those that has the cable installed in a rock area where the cable is in danger, they have to do even, they have to perform this activity even more than 2 times per year, because it's not only the only reason, because sometimes you have the sun movement over the year, and especially if the cable is laid in a rock area, the cable has not been applied appropriate protection. Sometimes the sun movement can bury the cable, and we have experienced this in the past, that the cable was properly buried, but due to the sun movement, the cable wasn't buried. And sometimes we need to make this exercise, which is going there and trying to bury the cable. That's why it's a good practice to leave enough slack to the cable. So whenever you experience this, you can go there and perform this activity. And this activity doesn't necessarily need to be performed by a cable ship. It could be performed by a diver in a small vessel, if you have this kind of service in your country. And there is one system called AIS, which monitor the ship traffic. It's highly recommended to the submarine cable owner to have it installed in the cable station. It gives you the info of every single vessel passing through your cable, whether it's in movement or stopped. Conclusion: the submarine cable operation and maintenance depend on the sea bottom profile, as I mentioned above. On the main cause of the cable breaks is third party aggression, natural factors as well as the seabed condition. Usually the cable is cut by big vessel carrying out the fishing activity, and some are due to seabed condition like rock area where the cable was not properly protected by following the recommended methodology of submarine cable installation. Thank you.
Thank you very much, Clementino. That was great. You know, as I mentioned previously, I just think that this is something that we haven't paid much attention to. I've learned a whole bunch of new acronyms today, and it's always amazing when you consider the amount of data that's moving through these cables and how important they are. And when you actually see it, just the small size of it, it's quite amazing. I'm also glad that you mentioned the AIS system. I remember during the cuts in January and April, the amount of press that was generated, certainly in South Africa, and you know, there wasn't a clear explanation of what had gone wrong, or a decent explanation of what the actual repair process looks like. But one of the things that did happen at that stage was there were 2 websites specifically that became incredibly popular. That's Marine Traffic and Vessel Finder, and so you had communities across the continent tracking the repair ships and giving daily updates on forums across the continent about where the ship was and how long it was still going to take for the ship to reach the location. And that was because people were suffering with a poor internet experience. So certainly, thank you very much for that. It was interesting. I see there are a few questions that have come up, and I'd just like to ask everybody, if you do have any questions for Clementino, please put those into the Q&A section. And I'd like to hand over back to Matthew now to run with the Q&A. Thanks, Matthew.
Thanks, Andrew. Clementino, thank you very much for the very informative presentation. And I see there's been a few questions here and there, and some of them that are already being answered from the panel. I've got some questions of my own as well. I mean, we are so used to operating on the land cables, and this whole idea of undersea cables is a whole different thing to us. Okay, you brought in just a quick question on the OTDR. I think it's very similar to what we do on land to locate the break. But we know that the undersea cable is like 2 kilometers or more in deep water. How do you actually get the cable to the surface to splice or to repair it?
Okay, that's a good question, and this is what people every time ask. Okay, usually when the cable arrives, when the cable ship arrives to the fault location, there is a remote machine that is operated from the vessel. The one is called it's grapnel or holding run. Usually they put that machine underwater to locate the cable, but it's not only the machine itself who locates the cable. Once they get to the fault location, there is a frequency, the tone frequency sent by the cable landing station engineers from the landing station to the fault location. And when the vessel arrives, they detect the frequency, the tone frequency, and then they put the machine down, the grapnel machine, to catch the cable and bring the cable to the vessel. The splicing is done in the vessel, not underwater. Once the splicing is done, then the process is, once the splicing is done, they put the cable on the buoy and they put on the water. Then they pick another side of the cable. They do the same, which is the splicing, and then they do the final splicing, and then they deploy the cable on the water. Basically, the whole process is done on the vessel, never underwater.
Okay, this is quite intricate. That's why we are having some questions here. Like we've got Fabrice from Tinka. He's asking, how do you get training to work on the cable vessel?
Well, as I mentioned before, we're not submarine repair. Okay, we are submarine cable operators. Okay, but there is a company which repair the cable. They usually have training, proper training to perform this kind of activity. That's why they're always doing the training every time to keep them updated and to keep them in a good condition in case of any repair. So basically, it's not us as submarine operators who operate or who do this activity. We just operate the cable, but we contract a company to perform the activity.
Okay, thanks. Fabrice, if you want more, you can always find Clementino. He can tell you exactly where to get trained. Clementino, just want to go into the economics of this a little bit. We understand from your presentation, you don't own the ships that repair, but from what you have been saying, it takes me 28 days to repair a cable, and the cable being so deep underwater. We just want to know the kind of economics. How much does it actually cost to repair a cable, or what is the kind of daily rate for these ships?
Okay, in average, if it depends on the situation, if the repair process takes you 28 days, as I mentioned, it can cost you almost 1.4 million of the US dollars. And the daily rate of the vessel is in average 20,000 US dollars per day, including the weather condition. Imagine that if there is any weather condition issues, that the vessel is in standby instead of operating or instead of performing the activity, you still need to pay those days as well. So it depends on the amount of the time that you stay during the repair that will lead you, the cost of the repair. But in average, it's 1.4 million, or sometimes even 2 million. But 2 million is maximum that we have experienced before, 2 millions, which is almost a month of a repair process.
Okay.
Repair activity, yeah.
Okay, thank you. We have another question. It could be answered by anyone, really. It's more about the data center. The question is from Fabio. Fabio, Jose. Most cables are linked to cable landing stations. With the move to cables, to connect directly to data centers, what are the possible impacts for this shift in cable and in land installations? So basically, they want to know.
Matthew, can you please repeat the question, please?
Okay. Most cables are linked to cable landing stations.
Yeah.
So with the move to cables to connect directly to data centers, what is the possible impact of this shift in cable and in land installations?
Okay, can I respond to this?
Yes, please.
Okay, I think, in this case, the impact, basically this is the impact of cable failure, because usually the cable landing station are directly connected to the data center. And then when we experience this failure, it basically affects the data center itself because of the backhaul connection between submarine cable and data center. In this case, I think if you have no restoration in place, it affects the data center in a whole. Yeah.
Maybe I can add to that, if you don't mind.
Yeah.
Mm-hmm.
Yeah, so I think it's a trend that has been building up over the last 4 or 5 years, because data center access and infrastructure at the landing station is not generally a core business for them.
Yeah.
At the same time, sometimes getting cross connects within landing stations has been quite difficult. So it's a trend that's been growing, especially where the landing station and the data center are not physically far apart. You're talking anywhere from 2 to 30, 40 kilometers. So it's a trend that's been growing in Europe. It's also something we're likely to see in Africa. I mean, Mombasa, for example, is a good one, with the landing stations not too far from, say, Ikolo, for example. You take, East Coast South Africa, where you have Tunzini landing station, not too far from, say, Teraco in Durban. You've got Azafontein, for example, in West Coast South Africa, that's not too far from Cape Town itself. You've also got Angola as well, Luanda across. We see some backhaul there. So it's a trend that's growing because the demand for connectivity in the data center is growing faster than cable landing station operators can deal with the demand or deal with that kind of scale. In terms of risk, the main thing is to have sufficient backhaul, or like a ring metro between the landing station and the data center. You can have your SLTE, which is just your line terminating equipment, which is basically the infrastructure side of the cable system in the data center. And you have fiber that's connecting them back to the main landing station, to the PFE, to provide power and so forth. But it's a trend that's actually growing, and I expect that we'll see more of it, especially with the new coming cables like Ikuyan to Africa, for example, because those are going to be quite interested in terminating data centers and not necessarily at the landing station.
All right. Okay, thank you very much, Mark. So moving on, we have a question in French that has been translated for me. So the question goes: what tools and software allow the economic impact of a cable cut in Africa in particular, and in the world in general?
you say what tools and
okay, let me repeat that, and the question has been edited for better reading in English. So what tools and software allow the measure or allow us to measure the economic impact of a cable cut in Africa and in the world in general? So are there any tools out there that allow us to measure the impact of cable cuts?
Well, from my side, none that I know of officially or specifically. I know there have been a few projects. I know Mehmet Aksin, I think, has been working on something to track submarine cable outages and their impact on society. I'm not sure how far he has gone with that project. Maybe someone else on the panel might know. But, and I know that at some point, some of the content providers are looking at building specific systems for the same also. And I know they came to us for some information as well. But officially, I don't know of any specific tool that measures this or that looks at this in any kind of official capacity. Maybe in private, but not something that I know of. Yeah.
A number of the internet sort of observing, people observing the internet like BGP Mon or something. If a country is down due to or severe, a lot of prefixes in a country go down, like DRC's cut off, or there's an earthquake in the Far East and things cut off. They do sort of publish impact and say, oh, this earthquake happened, and they correlate it to those drops in traffic. But that's the only thing I can think of. Yeah.
Yeah, I mean, on the IP side, just to back up what Ben is saying, on the IP side, yes, you will get some visibility because, that's ultimately what carry. But on the marine side specifically, unfortunately, it's terribly sparse information, especially during the failure.
Okay, cool. Thank you very much. So we are buzzing with questions. So the good thing is, if we do not answer any question now, we don't have time to answer the questions. Just keep them rolling in. We will respond to them in the chat. And even after the session, we'll still be answering the questions. The panelists will be there and they'll answer the questions. I've got two more quick questions before we move on. So one question here is, what risks or challenges are experienced during the maintenance of these cables? Do you want to take that, Clement?
Okay, Matthew, can you please repeat the question?
So, Clementino, so the question is, what are the risks or challenges that could be experienced during the maintenance of these cables? This question is coming from Aminu Ibrahim.
Okay, the risk, basically, as everyone might be aware, one of the risks in a submarine cable is the power cable, because the cable itself carry power, the high voltage. So whenever you're performing the maintenance, you have to be in coordination with the station engineers to make sure that, in case of any issue, they will power down the PFE. And usually the PFE need to be powered down during the maintenance process. So you have the other side feeding the power to the first repeater, for instance. Usually it only happens in the shallow water, where you don't need the power to be fed to the repeaters. So the risk is the power is the big risk. You need to be in agreement, in a coordination with the station engineers to power down the PFE.
Okay, cool. Thank you very much.
You're welcome.
Okay, maybe we're just about to conclude this session. I've got just one last question. It's all about learning. This question comes from Yolandi Robinson. Is there a way to learn more about the undersea cable work and where they are placed? I think this is more like a general question, really.
I think the best and easiest way is, I think, Patrick, telegeography. they cover a lot of where all the cable systems are. And there's also another website, I think Submarine something, might be of telegeography.
Submarine Cable Map, yeah.
That's the one, yeah, where they have all the cables. So yeah, there's quite a bit you can get from there, including what cables are coming up. But in terms of actual submarine cable operations, that would be very tricky to do if you're not inside an operator.
Okay, all right. Thank you.
Just
yes.
to add something here, yeah.
Thank you.
I think the general information about submarine industry, I think you can find anywhere in the internet, but the detailed information of how this is operated, how this is performed, I think is this industry is very close industry, and as has been mentioned, you need even to be in a company where they perform this kind of activity, or a telecommunication company, or submarine submarine cable operator, etc. But the general information, just to be aware of how the cable looks like, how the operation is performed, I think this is published in the internet. You can find it anywhere.
Okay, thank you very much, Clementino, Ben, and Mark. Thanks for chipping in with some answers to the discussion. I'm handing over to Andrew now.
Yeah, thanks very much. It seems like the panelists are chomping at the bit to get going, and decided to jump in a bit earlier. So let's just get going. So welcome to our panelists. I'm grateful to have some familiar faces. I'm sure you recognize all of them. They've all been heavily involved in, I guess you could say, the evolution of the internet on the continent. So thank you very much for your time. So we're going to start. We've got Mark Tinka, Head of Engineering at SEACOM. We all know Mark. We all know that he's been involved in many different aspects of the internet over the years. We've got Ben Roberts, Group Chief Technology and Innovation Officer at Liquid Telecom. Liquid Telecom obviously has an extensive, highly interconnected network across the continent. We've got CK from Akamai. He's a Senior Director of Network Architecture. Akamai has obviously had a significant impact on driving internet adoption in Africa, and has changed the way that we use the internet and get the internet out to end users. We've got Mohamed Ibrahim, who is the CTO of United SAS, and that, I learned today, is the most interconnected network in the DRC. Finally, as evidence of the fact that the year 2020 is not done with us yet, Patrick Christian from Telegeography was unable to join us today due to an emergency. But fortunately, Matthew has graciously agreed to cover the data that Patrick provided, obviously without the accent and the West Side jokes that Patrick has become renowned for. So Matthew, if you want to get going with those slides.
Thank you very much. Okay. Thanks to Patrick for preparing these slides. He was going to be here, as Andrew said, but we just go through his slides so that we can just give a good context to the panel discussion. So we are talking about the international capacities. We want to look at the international capacity and how fast it's growing, and how and where it is actually connected. So from this slide, you can see that Africa is the highest international bandwidth growth rate. So he says that the cumulative annual growth rate for Africa is like 47%. So between 2016 and 2020, we had like 17.7 terabytes of increase in capacity. So within the 4 years, the capacity has more than quadrupled, which is quite amazing. And also note from here that the connectivity is mostly to Europe. About 81% of the international connectivity from African countries connects to Europe, and Africa is still very much dependent on the content from Europe, just as much as we see Latin America being very dependent on content from the USA. Andrew knows that it seems like it has been 80% of the traffic that comes from Europe to Africa. It's been like on 80% for a while. But the interesting fact is, if you remove North Africa from the equation, if we just look at sub-Sahara Africa, we know that 60% of the international bandwidth, 60% of the international bandwidth goes to Europe. So the Southern Africa does not only connect to Europe, but about 40% of it does actually connect to. We see United Arab Emirates there. We also see some connectivity to other continents like South America. If we look at Northern Africa, like Morocco, Algeria, Egypt there, we see that almost 100% of the capacity in North Africa is actually connecting to Europe. So it goes on to the next slide to talk about the intra-Africa capacity connections. So here it looks at the connections within Africa itself. One thing to note that for all Africa, 16% of international capacity is intra-Africa. And it did the analysis of taking out the North Africa as well and just looking at sub-Sahara Africa on its own. Then if you take out North Africa, in sub-Sahara North Africa, about a third of the traffic is intra-Africa. Also, he noted that there are some obvious hubs within Africa. South Africa being by way the biggest, and a bit of Nigeria there, and in East Africa we see Kenya and Djibouti, and in North Africa, Morocco and Egypt as being some of the hubs. Then on the next one, on the next slide, we'll talk about the cables. So Telegeograph have noted that there are 64 cable systems active in Africa. Of the 64 cable systems, 36 of them connect to Europe. 14 are intra-African, and 14 are domestic cables. One interesting fact is that of the 36 cable systems connecting Europe, 21 are from North Africa, and only 15 are sub-Saharan Africa. So it just shows that we still have a very big gap between sub-Saharan Africa and sub-Saharan Africa and North Africa. Also, the same can be talked about on the cable landing. I mean, the more cables you have, the more the landing stations. So there's also, he did an analysis of the cable landing stations within Africa. So we have about 32 countries with coastlines. Only about like a third of them have one cable landing station or no landing station, with most of them fewer than 3 cable landing stations. And we know that there are only a bunch of countries with 5 or 6 cable landing stations. Of note, it's South Africa, Nigeria, Kenya, and Ghana. These are the only one with 5 or 6. Most of the countries do have 3 or less. So this goes on to underline the fact that, well, when it comes to the paths that we have, or the alternative in terms of redundancy, we have limited cables to connecting, especially from South Africa to Europe. So we have noted that there are only 2 cables on each side connecting South Africa, or the southern part of Africa, to Europe. And on the west side, one of them is very, very old. And this underlines the fact that we have very little redundancy. And also, to the discussion we're having today, there's a whole big cut, there's a whole big risk. If we have only 2 cables, with one very old, if there's a cut, then there is a very big risk of redundancy, and there's lack of diversity. So thanks to Patrick. Over to you, Andrew.
Thanks. You don't sound like Patrick at all.
I was trying my best, but that was his message.
Okay, so we've got a quick poll question that we're going to put up. Thanks for that. So, audience, if you can just go through this list and answer that question. While we wait for that, I was very interested in the data that Patrick sent through. Just the number of active cables is quite astounding. I mean, 64 active cable systems in Africa. The other interesting point was the intra-Africa connectivity, and I'm hoping that's going to come up during the panel discussion. So very, very interesting stuff. But you know, much like peering and everything else, this is all up and to the right. If you consider that Africa has, I think it was in 2020, the highest compound annual growth rate in bandwidth at 47%. So that's that's quadruple of what we saw since 2016. So that has been very interesting and quite significant, and shows that at least in some areas we are getting things right. Okay, so we're just going to leave the poll questions up for a couple of seconds before we get the answers. Okay, and there we go. Yeah, interesting. Interesting to see there that the majority is that there was no impact, with the implication that people have diverse paths. Certainly we, based on the amount of noise that we saw from the press and from a lot of ISPs across the continent, I kind of expected a different result, but that is interesting. We can also see there that at least one person was completely offline, and at least 2 people are not honest in suggesting that they do not use the internet, since they are currently using the internet. Okay, interesting results. And I think let us get going with the panel questions. So I think the first question, given that we know about the cable cuts that we had at the beginning of the year, I just want everybody to just give a brief explanation,
je voudrais expliquer
en bref the impact that they had on l'impact qu'ils ont, what was relevant to them. So I think if we can start with,
qui est pertinent.
Tell us about your experience.
Est-ce que vous pouvez raconter sur votre expérience? Oui.
Yeah,
Merci, Andrew.
The experience you get as an operator depends upon how you've engineered your network. So by default, as the way we engineer our networks is that we use, to most countries where we can, we try and use 3 or 4 submarine cable systems to serve that country. And that's the ideal when it comes to, it's a simple equation. If you use 2 cables, you can get 99.9% redundancy or availability. If you use 3, it's 99.99. To achieve 5 nines, you need 4 cables, really of any kind of group. So we were, although there was two subsea cable cuts in this particular instance, we were in some way lost a lot of capacity from wax being down. We had small amount of capacity on SAT3 at the same time. But really, we'd engineered our network in such a way that we had able to carry all of our South African traffic by the East Coast route. So, we didn't feel any impact for our customers. But much as the cable cuts can be a risk to your business, it can also be an opportunity to your business. So, what we found is that, a number of people who had never been our customer before, and some of the oldest telecommunications companies in Africa even, who'd never, would have dreamed of buying internet from the old liquid telecom, suddenly were needing extra capacity. So we had, I wouldn't say a glut of capacity, but we had enough to serve our customers. So we look after our existing customers first of all, but we had a certain surplus that we were able to, then offer to those operators who wanted to take it on, but on the understanding that it was preemptive. If a third cable got cut, we would have to probably, sacrifice that short-term contract and serve the long-term existing customers. So, ultimately the priority is for your customers, and you keep your customers up and running, and then you're looking for opportunities. But if you're in a situation where you are having to do some restoration, you then be calling up, you'd be on that other side, or be calling up other operators, and I'll talk about that a bit more.
So every cloud has a silver lining. Mohamed, I think your experience was potentially different. Can you tell us what you experienced?
Différente, je pense, oui. La connectivité est basée en Afrique de l'Est et
the wax was down, we were down for 6 hours. So we had to reroute our traffic to Angola, and then from Angola to Brazil using the SACS cable, and then from Brazil to the US, and then from the US back to Europe. So actually we experienced a lot of latency. It affected us a lot, and actually we started searching for a shorter path, and we built up some time because we had 2 issues. One of the issues is that most of the BGP peering that we had that were created temporarily didn't allow all our prefixes and our client prefixes to go online. So we actually had to tunnel up some of the connections, okay, and use our routers in Europe that already allows this kind of prefixes, because most of the operators in Africa actually don't work on based on IOR and records. They work with manual filters, and they need a letter of authorization and to allow. And with this short span of time, we couldn't hand over all that. So actually, some of our clients were down. And because of because everybody almost used the same path, these paths were saturated. So a lot of people used to use they separated wax into wax north and wax south. So everybody was sending connectivity back to South Africa, and then from South Africa to the SEACOM or using SACS. So latency was at least 200 milliseconds more than what we used to experience usually.
Wow, and that must have been quite a frustrating time. I mean, 200 milliseconds is significant.
Yes, and we actually told the government that normally projects like CAP5 should be, if projects like CAP5 had existed, we wouldn't be down, because Congo will be taking connectivity from Lubumbashi and then only to Telecom, and as well the same through Goma and to different countries like Rwanda and Kenya and Zambia. But since we only rely on one cable, and actually we rely, in our topology, we rely on Brazzaville and Congo Brazzaville and Mwanda landing station, and both of them are only connected on the WAX CLS, and that's because there is no other options. Okay, so we are one of the one that are waiting the most for new cables and new opportunities, and actually more land connected cables.
Okay, cool. CK. So Akamai obviously shifts a significant amount of traffic on the continent. Is there any impact on the Akamai network? Is there a change in how you map networks to certain caches or clusters? What do you see from your side?
So when you hijacked me for this panel and said, you know, the topic is the big fiber outages and the big fiber cuts for Africa, I thought, damn, did I miss them? So then I actually had to go back and see what we have seen on our side to actually, you know, see what it meant and why I, at least personally, kind of missed it. And I think it was not a big deal for us on our side. For people who are a little bit familiar with us, we have two kind of clusters, right? We have the clusters which are the caches in an eyeball network. So some of them have seen a performance degradation, but none of them was offline. So at least we didn't place caches in a network which was then offline afterwards. And we might have fine-tuned some of the parameters there, but that was really the extent. The caches which have transit and they have probably a different use or different purpose, and most of them are probably in South Africa anyway. We actually had transit providers which had apparently enough capacity, so we didn't see much. There might be a little bit of latency, but from a performance or, you know, from a throughput or any other KPI, there was actually no impact on us. So from that side, I don't know if it would do anything particularly different for the future. One of the parts which crossed my mind was we started to build a backbone around the world, and we are now in year 3 or 4. The continent which we haven't gone yet was Africa. So when the panel came up and I thought about it, there was the question, how many fiber providers do I think I want to have in the future, and how would I actually build it if I build it myself? And if I need something there, because so far I probably would have said, yeah, 2 is good enough, 1 left, 1 right, whatever. Now I might reconsider that part. But no, the other part was fine. Nothing spectacular from our side.
Thanks, thanks, CK. Mark, obviously in January and April, SEACOM wasn't affected at all. I joked a couple of years ago on a panel somewhere in New York with a carrier, and I asked him, when he goes into the Ferrari dealership, does he pay cash via EFT or does he just take a suitcase with him? So you guys having obviously a lot of capacity, did you see a lot of emergency upgrades or emergency connection requests?
Yeah, so obviously there was a lot of requests for restoration. Being that we operate both a transport and an IP network, you've got different kinds of requests for restoration. So most large service providers want to restore on transport, but the challenge you get with that is, especially in Europe, is you can't get cross connects within 15, minutes or 15 hours for that matter. So it takes quite a long time to get a cross connect in a major data center in Europe, sometimes as much as 5 days to a week. You do get that also in some facilities in Africa as well, depending on where they are. So then because of that, you find some of those operators would be willing to consider IP as a restoration capability for us that period of time. But yeah, you do see quite a bit of a scramble, and I suppose it's normal. For me, cable failures is always a case of when, not if. Any cable operator will obviously have at least a plan for at least 1 or 2 failures a year. It's a lot of money to insure for that, but sometimes it might happen, sometimes might not, but you always plan for that. This year it was WAX and SAT3, anytime could be SEACOM or vice versa, right? So it's always great to have relationships on standby that you can lean on in either direction to get a resolution.
Cool, and that leads nicely into the next question, and I'm going to direct this to Ben and to yourself, Mark. I know that we in our facilities always see, like you say, a flurry of interconnection requests, emergency physical cross connects whenever there is a cable outage. So tell us about is there sort of a gentleman's agreement amongst all of the carriers and submarine operators? Is there, a willingness to help each other out?
Let me take that, Andrew. When this sort of thing comes about, I think some of the rules, the rules of normal engagement change, and Mark and I, we are, people in the engineering teams in rival competing companies. Although we companies trade a lot with each other, we're also rival competing companies. And I know Darren Bedford was supposed to be here on this panel, and he's with Wyatt, and he's also an engineer working in another professional working in a rival company. And then we have a different relationship. Once we get outside of work and we're at a peering conference, we're probably friends, so we will have a beer together and we're friends. But when it comes to this situation of a cable cut, these guys are my family, right? These are my brothers. I need some help. Who do I call? I call Mark, I call Darren, I call my brothers to help me out because I need someone to help me. And so the normal conversation we would have about, oh, give me a quote for this, the price of that. You start talking directly engineer peer-to-peer to find out what you can do. We don't even start talking about a price. We say, what have you got, Mark? Have you got any capacity? Can you help? And then, tell me honestly what they can do. If they can't do, then I'll go and call somebody else. But so you kind of work out the feasibility of what can be done in a short time at engineering level. Then somebody will put a call into the sales department and agree a price and you bang, there's no need for then signing complicated orders, an email suffices. The engineers get to work on it. And much as then, the guys in the other cable operators, they might be my brothers, people like you, then we call the data centers, you're my cousin, right? And we need you to do a cross connect. We all need everybody to work on it. The problem is when we get to Europe, as Mark alluded, if you want to get something, I remember a 2013 incident, and we were trying to repatch 10 gigabit circuits in Marseille, and then you hear that an engineer in France has gone off on holiday for the weekend, and it's a bank holiday on Monday, and he'll be back on Tuesday, and you've got a whole continent of customers suffering. So the spirit of brotherhood probably weans off as you leave the continent, but we do our best to help each other as engineers and peers and colleagues.
Yeah, I think just to answer your other question regarding the pre-arranged capacity, unfortunately, it's not always possible because, especially particularly with consortium cables, it's a bit tricky because they would have specific, landing arrangements and cross-connect pricing and so on and so forth that would make it either unpalatable or almost impossible unless there's a real request that would last, a certain number of months or years to have, cross-connects and capacity on standby. So that's always been the biggest problem, at least for us anyway, in trying to have some capacity on standby. Because, as a private cable, we would be able to do that. But, if I go to a consortium cable, they might need to consult the landing party of 2 different countries before they can agree on an end-to-end cross-connect. So that kind of thing has been quite challenging. I haven't yet found a real solution at the moment, to be honest, but it's something that we're trying to work on. So what tends to happen is that, say that you're going to have an outage because you're going to plan a repair, for example, then yes, you can pre-arrange capacity, to give you that coverage for the repair. A non-repair could take anywhere from, 2 hours to 2 months, things like that happen. But in the case of emergencies, it's always a bit of a lottery. You might have capacity on the other system that's available, you might not. So yeah, if there was a way that we could somehow figure that out, I think there's enough people that know each other well enough in the industry to find a solution, but we still haven't gotten there. So yeah.
Cool, thanks. Okay, next question. I'm going to keep you on this one. given that you have quite an extensive land network across the continent, and I'm going to ask Mohamed to comment on this one as well. Regulations across the continent. I mean, we've been speaking about this for as far back as the beginning of AFPIF. We saw from Patrick's slide I guess you could call it the low number of intra-African connectivity. And we also heard CK saying that he might want to consider a third path, for example. And if you think about it logically, that third path could be a land cable, taking you from the bottom of the continent right to the top into Europe. So where are we getting it wrong, and how are we going to fix this?
I don't know we're getting it wrong, but I've been saying this for a while. Africa is still big, and some of the distances can be quite long. So we have a very interconnected land network, but the economics of it are that when you get to long distances of 2,000 kilometers or more, sea cables are cheaper to lay, cheaper to maintain, and they probably have less cuts. They might take 28 days to repair, but they probably have less cuts than a 2,000 kilometer fiber. So we talk about, Matthew's talking about sub-Saharan and North Africa. The fiber links that are crossing the Sahara, I think there's two, but probably very little used because the cost is quite high of leasing capacity on those cables compared to using wax straight to Europe or using going through Egypt on their extensive terrestrial systems that cross through to Alexandria. But we've seen it really come into play. South Africa is a good one because it's one country, but it's got a few different very diverse places where there are landing stations. So there might be cuts for some cables that land in Durban, but cables that land in Cape Town are fine. So okay, it's one country, but it's on the large side. But in East Africa, we've got a really good level of backup. We have what we call an East Africa ring. It's a high capacity ring. So when Tanzania has been cut off from the internet for any particular reason, cable cuts and shunts, we have been able to route internet traffic from Nairobi south straight to Dar es Salaam via Arusha, straight that way, keep Tanzania up online. A country like Rwanda, being landlocked, is actually just equally sharing its capacity from two countries. It doesn't have a landing station, but it's able to take capacity from Kenyan landing stations, Mombasa, and also Dar es Salaam. So it's able to trade that. Somalia is another good example. From Kenya, we have a good cable from Nairobi to the border of Somalia, and there have been some instances where Somalia has been completely suspended. There's only been one cable until recently into Mogadishu. So that spur has been cut a number of times with long repair times. But one of the operators who is a customer of ours and buys capacity from the Kenyan side, albeit more expensive, they have managed to not be off the air. And even if they have less capacity than they used to, it still gives them the opportunity, as CK was saying, to keep their caches online. They can use that capacity to serve their Akamai caches, their Google caches. That can really help a big difference in keeping some of their internet connectors and keep people working, keep people using YouTube and using Akamai downloads. So it can make a really big difference. I think we have done this big fiber optic link across DRC, which is our sort of first really big east-west crossing. And we have internet going up to Lubumbashi in southern DRC, and people in Kinshasa will be able to take internet from that. So in the event of everything being suspended on the west side of DRC, they're able to take everything from the south. So there certainly are opportunities coming, but they come at a slightly higher cost in terms of the per kilometer rate of laying and maintaining fiber. You're muted.
Mohamed, anything you want to add to that?
Yes, actually, it's regarding the existing infrastructure, especially on land. Many of them were not well done, not done in some norms, and some of them actually are in a very bad shape and very bad condition. And actually, it's very hard in some African countries to get a license to put another cable because in some countries they consider it as a national security issue. And that's one of the reasons actually where they refuse to interconnect to other countries. For example, many links in DRC to Rwanda, they are considered illegal because Rwanda is had some issues in the past with DRC, and the same with other countries. And that actually is one of the biggest problem, I think, for future interconnection in the continent. And one of the things is that they need to understand how important the internet is becoming in our life, and they need maybe to have some education regarding how it's because one of the big problems as well is that they don't have any interest. Some of the people that are supposed to manage or give authorization don't have the interest for the companies to lay out fiber or to improve the existing infrastructure. As long as it works for them, they don't make a difference between if it's faster or not. For them, it works, and that's enough. Like when we explained that there is a necessity to have several landing stations, they said there is already one. Why should we have another one? Yeah. So there's many other, and of course it's very expensive to lay down cables, and as Ben said, it's cheaper sometimes to have on the submarine. But the problem is that some countries in Africa are not coastal, and most of them actually are very, very big. And there is a very big difference between the cities, so it doesn't make any viable economy to connect. Because there is no clients, or not enough actually internet penetration, or sometimes it's not enough power of buying. Actually, they don't have pouvoir d'achat. They don't have enough to be able to buy internet, and internet is still very expensive actually in DRC or in many countries in Africa compared to all the connections and prices we have. Many people compare, like always put South Africa in Africa. I suppose South Africa is only Africa by name, but in terms of technology, infrastructure, they have it all, I would say. In the cut in January, actually, some of the CDN we have, like the Google Cache and all the others, actually saved us a lot. If we had much more, I think the clients wouldn't, or the customers wouldn't feel the impact, because a lot of our clients didn't feel the impacts regarding the CDNs that we have installed. All the rest were especially real-time application, were felt because of the additional latency. Yeah. So I suppose that in the future, what we will need is more submarine cables and more actually inland cables, and maybe more data centers to interconnect all that.
Well, thanks. And speaking of caches, we've been speaking about SAT3 and WAX. I remember in January of 2016, SEACOM had quite a significant cable outage. And I recall specifically at the Internet Exchange in South Africa, at Map Africa, we lost 60% of our traffic coming across the exchange. So Mark and CK, we all assumed back then that because we had these CDNs coming onto the continent and serving all of this content locally, we kind of assumed that the criticality of the submarine cables kind of fell away, but that was obviously not the case. What is? I mean, how do you mitigate against something like that?
So CK is the CDN operator, so he can shoot me if I'm talking out the side of my neck. So I won't speak for too long on that one. But what I know in terms of CDNs is you might have two types of operations. So there would obviously be cache fill, because I think over time, a lot of ISPs have thought of CDNs as having static content that almost lasts forever. But my understanding is, and again, CK can correct me here, is that cache fill would happen specifically for content in real time. So, you request a website, it hits the cache picks it up, sends it to you and saves a local copy for a certain amount of time. And if that amount of time expires, then it has to pick it up again. Then there's the other method where the content is preloaded, say, in a specific hour. So say Netflix, for example, they would fill the next library of movies and content, say at 3 a.m. every morning, right? So between then and the cable cut until the next fill, you probably won't have updated content, but you wouldn't know because, well, what's there is what's there. So again, CK probably knows that better than I do, but that would be my simple 1 + 1.
I guess that was a good start. I have to speculate a little bit about our Netflix friends, but in general, what we do is, right, we cache the content as it says. So you have two aspects, actually. Aspect number one is we have to see how long our customer actually tells us that we can keep the content and how dynamic the content is. That is actually mainly defined by our customer. But whenever that content either expires or we need additional content, we have to go and fetch that content. There is the majority of that goes back to Europe, US, to either other cache hierarchy nodes, which we have, but usually it kind of leaves the continent and the country. So if that connectivity has an issue, then the cache has an issue, right? So I guess we can live with a certain amount of connectivity. So we basically say the cache is not the fast and then it takes longer till he populates it. But then when he has it, he actually can serve it out and all is kind of fine-ish. The initial part might be slower, but then afterwards it works and it's fine. At the moment where we actually lose connectivity to the cache or our monitoring system declares the cache as so badly reachable, we actually start to shut it down and don't send end users there anymore. Because you also, can't get origin fetches and stuff like that into the cache. So in that case, if a service gets to a certain point, we actually send the African end users, even like South Africa, back to Europe. And then we make the remaining capacity on the submarine cable worse, because whatever the offload factor was before is now all bouncing back to Europe and back to the submarine cables. And now I'm speculating over Netflix. Let's see if I ever get feedback on that. It's certainly true that Netflix or the people who own the content, which we don't have, and especially in the case of video on demand, they can pre-populate the cache. So I guess that's all good, and they either have it already in or they do it when there is enough bandwidth in the night, whatever. But I would assume that at the moment where the mothership, wherever they are and however they control their own cache, loses reachability to the cache, that they actually wouldn't send end user there anymore. Even if all the movies are in, if you don't know how much you send out and who actually connects to it, then I think you basically redirect your end user somewhere else. So a complete loss of connectivity, I would assume, even to the ones who can pre-populate outside of the regular busy hours, would bounce back to submarine cable. So, yeah, sorry, as a conclusion, probably, I think the caches are very helpful if you have a certain amount of connectivity, because then we are good for the reliability and the speed. But if the service is so much degraded that we have an issue with the cache and we lose the cache, then it's actually worse than before, because now the remaining submarine capacity is also shared with the content, which was in country before.
Okay, thanks. All right, so we are very close to time and slightly over time. So I just want to get a quick comment from some of you. We have to Africa and Equiano coming to Africa. Do we have enough submarine capacity, and do we need more? And what do you think briefly is going to be the impact? I'll start with you, CK.
As I said before, now when I actually think about if I go with my own POPs to Africa, probably specifically to South Africa, I was never worried about the capacity. Can I buy enough 10 and 100 gigs or so? So the cables already had enough throughput. But when it comes to a reliability question, which kind of cables would I buy in, which kind of combination? I think better is always, or more is always better in that case. So I think we should have more.
Mark Tinka, you've always got something to add.
No, I definitely think more. So I mean, there's never going to be enough capacity, and a lot of cables is now starting to get a little bit older. I mean, so you're going to need more cables to come online, and that's a good thing. I think Equiano and To Africa obviously going to are using slightly different models compared to the earlier ones. For example, direct data center delivery is one aspect, which is great. That means you're going to see a lot more interest in more data center capacity in major cities across non-traditional countries beyond, Kenya, Nigeria, and South Africa. So yeah, I think definitely, obviously, like at least from our side, we are seeing quite a bit of shift now from demand away from cross-continent, so from Africa to Europe or Africa, Asia Pac, and we're now starting to see more demand within Africa now, regional. Especially with more data centers coming up, there's a lot more demand, say, between Kenya and South Africa, say between Tanzania and Uganda type thing. And I think for the foreseeable future, that's going to be where a lot of growth is going to come from. I don't expect to see the same levels of growth from an operator standpoint between, say, Africa and Europe. I would see that more for the content providers because they're the ones building these new cables. But from an operator standpoint, I definitely see more submarine opportunities between African countries.
Great. And then, Mohamed, you wanted to say something about this particular question?
Yes, actually, sorry because I was reading some of the questions and some of them were interesting. So I lost you a little bit. What was the question, please?
Oh, the question is, do we have enough submarine capacity in Africa?
Yeah, I think there is enough. And because if you look at how much percentage is activated on the WACS, I think it's there. They didn't even reach 10% of the activated capacity. And for example, when I look at what we activated already in DRC, it's not even 1% or what they have actually subscribed on the WACS cable itself. So I think, and for a very long time, especially for the first 3 years, the cable, the existing terrestrial cable couldn't handle more than 10 gigabit, the whole total capacity going to Kinshasa. So it was a very big issue. And it's only recently that they upgraded, and still the upgraded one is not working properly to activate more on the submarine cable. So I think that bringing more cable or bringing more submarine cable capacity won't help the DRC. What will help, I talk about DRC in particular cases because we are more focused over there because we're from there. I was born and raised in DRC, so I have a particular interest in the area. So what most of I think it's the case as well in all Africa, that most of the existing terrestrial infrastructure are not fit to accommodate all the submarine cable coming from outside. And a lot of them don't have neutral data center. They don't have enough CDN. And it's actually very, very hard actually to acquire CDN in Africa because we cannot meet the same demands that are in Europe. For example, to apply for an Akamai, you need to reach some milestone that it's very hard to reach in Africa. And it's actually even hard to ask and acquire for them. So that actually could help a lot the African countries to get the CDN easier, and it will help much more than having more submarine cables. The submarine cables, I think, would be just for redundancy more than additional capacity.
I think maybe just to just counter a little bit on that from Mohamed, I'd say from a capacity standpoint, maybe, yeah, we probably might have more capacity right now than we're able to consume, but the lack of being able to consume that is other reasons, most likely related to price and not enough competition in specific markets. So I think in the worst case scenario, additional cables should add pressure in evolving the economic models that allow more people to get capacity at more affordable pricing, at the very least.
Yeah, but for example, on the WACS, I would be glad to maintain the same prices that we get. We pay 3 to 5 times more for the last 500 kilometers or 600 kilometers than what we pay for the 8,500 kilometers coming to Europe or going to. So the problem actually is still terrestrial. And that's because they don't have enough capacity. If they had, let's say, several hundred gigs terrestrially, they will reduce their price because they will have a lot of capacity, and then it will be solving an issue. And reducing the price of internet will make it more affordable. More people will be able to connect, and then you have more demand on capacity. So imagine a city like Kinshasa that have 17 million person have 20 gigabit. I have 10% of that capacity at home here. So that's not normal for a country that big or a city that big.
So, I mean, maybe I can chime in because, you know, I've written a 2016 blog about this, about cables and, you know, do we need these extra capacities? And I don't think, we're not seeing the demand for capacity right now, but obviously the new cables are being built by some global companies that do, you know, the way they're architecting their networks and they're connecting data centers to data centers. You know, there's a lot of money been invested into these new cables by people that really do see the growth, and you know, not to question them because they understand how their data center to data center connectivity works. But you know, certainly when you look at the data from Patrick Christian earlier, you see that the bigger countries, the bigger using countries that are using the most bandwidth, Nigeria, South Africa, Kenya, Egypt, Morocco, you know, these countries are using you know, a significant chunk of data, and they do need more capacity, and they're going to need more capacity. The countries that are not using maximizing their capacity, maybe like DRC, are probably thinking they don't need it because you've only lit this much capacity on these cable systems. But the new cables are going to come. They're going to come with new landing parties, new landing stations, new people providing backhauls, and we are, you know, we've made it public that we have a license, applied for license in DRC to land Equiano. So they're going to come and make a difference. So I see that the new cables are going to have more difference to make in cables that only have one or two, you know, countries that only have one or two cables right now. They will still have a big impact in price in South Africa, but they're going to have the biggest impact in countries, you know, that have maybe less landing stations, more gatekeepers keeping the prices high, that sort of thing. So you know, I expect change, I think, coming from this, but it's not entirely about the capacity used. It is about economic benefit. Though I would, you know, I don't want to overrate the economic benefit as well. There was a report came out from some consultants, RTI, last week. Some American consultants wrote a report which was largely fantasizing about the future impact of the new cables that's coming. And I think the economic impact is you know, from the pioneering cables has already come, and I think you know, it's going to bring down prices, but it's not going to have quite such a revolutionary effect. It's the investment in the last mile that's going to be really needed to take up this capacity. We're going to have more fiber to the tower, more 4G, more 5G, more 5G frequencies available, more fiber to the home, and we can't consume, as operators, we can't consume the capacity. The cloud guys can. They're doing data to data center connectivity, so they can consume the capacity. But we as operators, we need to see, you know, cheaper frequencies being allocated and less expense to wayleaves, less expense to rebuilding fiber when the road authority digs it up. So these are the things we need to see changing.
Thanks, Ben. Guys, thank you very much. We've run out of time. This is obviously a topic that there is a lot to talk about. So it's possibly a good idea to do something like this again. Thank you very much for your time today, guys. I really appreciate it, and it's been very insightful. I'm going to move on quickly by saying another thank you to the sponsors. Again, the virtual peering series started because of the pandemic, and without sponsors we wouldn't be able to do this. So from Flex Optics, Fergus, Renee, Marcus, and Portia, they are the sponsors of the simultaneous interpretation. We want to say thank you to Ben and Andrew from Facebook, and then lastly the team at NAP Africa, who have been series sponsors for all of the VPS series, and will also be sponsoring the next event. I mentioned earlier that this was going to be the final event of 2020, but we do have a social event coming up on the 8th of December. If we can just get that up. So we're going to be trying a virtual Beers for Peers social event. It's going to be online, obviously, and we want this to be a sort of a peering bilateral session. The registration link is going to be pasted in the chat room, hopefully now, but you can also scan the QR code on the screen right now to get to the registration page. And this will also be available on the AFCIF website. And then we're looking forward to doing the 2021 session. So we found that there's been a lot of interest in these sessions, and attendance has been very good, and there's been a lot of people attending and asking questions, and so we're going to be carrying on with these. The next session is going to be in Feb 2021, and it is about franchise versus homegrown IXPs. And I know that the team is going to be looking specifically at various models of building internet exchanges and which model works in particular situations. Okay, and then that is going to be it from us. Thank you very much for attending. I'm going to hand over to Michuki to do the virtual peering personals.
You're muted, Michuki.
Sorry. Well, sorry about that. So thank you, Andrew. That was a great session, and welcome to the peering personals session. We don't have many of them, so we'll just go quickly through them because we are running late. So the first one up is Kyle Spencer for UIXP.
Thanks, Michuki. I hope you guys can hear me. I'm doing this from my mobile. This is, yeah, we're the Uganda Internet Exchange Point. We're AS37386. We're in Kampala, Uganda. We've got 29 networks connected. That's a lot of access networks. We got a competitive access market. We've got carriers, content delivery networks, education networks, the government network, even enterprise networks, and then the usual smattering of DNS and other academic research sort of projects. We have a very healthy multilateral peering ecosystem on the route servers, but of course we also allow bilateral. If you're interested, get in touch with me. The contact details are on our website. Thanks.
Thanks, Kyle. Next is Angola Cables, Clementino. Maybe you could talk through this one.
Hello, sorry, can you please repeat?
Could you talk through this slide on your peering personals? I was advised you'll be the one speaking through this one.
I'm not getting the question, please.
No, just talk through the slide that you see, introduce your AS number and where you're peering. Can you see the slide?
Yeah, I can see the slide.
Yes.
Yeah, I think it's breaking a little bit. Okay, peering points, IXPN Lagos, NAP Africa, Cape Town in Johannesburg, Angonix Luanda, IXB BR Sao Paulo Fortaleza, and the Rio de Janeiro. NY IIX USA, DKIX Frankfurt and USA, Hispanics Madrid, Franksel Marsella, Asmix and Link Londres, Gigapix and DKIX Lisboa.
Okay, thanks. All right, the next one up, I don't see anyone from Vodacom DRC, Jean Cloud, but if there's someone from Vodacom DRC who would like to speak, put your hand up. I'll give you the permission. In the meantime, Benjamin, Ike.
Sorry, just if you can return to the slide, one slide before, the one of Congo. It's saying that peering policy is open. I very much doubt so. It's so hard to get into the Kinix or the Lubix, actually. I'm actually peering with the Kinix, but indirectly, on the personal level. And actually, Kinix is kind of, I wouldn't say it's open, because they ask for so much paperwork and it's politically motivated, and sometimes there is a political blockage in it from the other ISPs, I would say.
Okay, so all right, that's something we can certainly take offline with you and follow up, because we work very closely with the IXPs in the region. So happy to follow up that with you.
Yes, and actually regarding that, normally the market is should be more open than it is today. Today it's not very open. I'm not just talking about the exchanges, but in regularly it's not very open, and some of the operators actually take some situation to control other part of the market, unless although internet is supposed to be open. And, yeah.
All right, thanks, Mohamed. Okay, so moving on to Ike. I hope I pronounced your name well.
Yeah, Benjamin Ike Anyang. Yeah, PR is 37148 for Globacom. We peer in Lagos, Accra, and UK. Peering policy is filtered using AS 3748 and AS Globacom. And we can be contacted at benjamin.anyang@global.com.
All right, so thank you very much for those people who send in their peering personal slides, and we hope to do this at the next event. So that is the event on the 8th. For those who register, we will invite you to do the peering personals before we start the session. So next on is, I will walk you through, we normally have scheduled this to end and give us about 30 minutes of social opportunity to meet with others. And today we've run out of time, but I hope you still have a couple of minutes to meet the folks who've attended. So I'll just walk you through very quickly through the tool that we will use for the virtual social. As